I want to comment on the Tesla AI Day. It just finished. My thoughts, my expectations, midterm and long term for Tesla based on what they presented at the AI Day. This is the Not Even Wrong podcast. It's August 19th, 2021. This is Cryptelco. For the day, the fund is down 3.6%. The market is up 10 basis points. We are up 1.7%. For the year, the market is up roughly 17.6%. We are underperforming by 15.9%. Tesla just finished their AI Day. They had a couple of people presenting. Of course, Elon Musk was presenting. I want to go quickly through chronologically what they presented and then share my thoughts on how I feel about it and my expectations. So Andrej Karpathy started off, and I want to maybe use this as a sort of structure of how Tesla is managing their self-driving business. So we have vision, we have planning, and we have the computer architecture to support this. This is roughly how they look at it, and this is also how they present it. So there's first and foremost the sensory suite that is necessary to gather information and make sense out of the world. This is Andrej Karpathy's business. He's the director of AI at Tesla, and he's particularly focused on vision. And then we have other people, and I'm sorry, I don't know the names now, but they were presenting, and they were at least 4 or 5 people. One of them, an Indian gentleman, he is in charge of planning, and that was very interesting. So once you have a representation of the world in some sort of model form, I'm going to discuss in detail how that works, but you look at the world, you gather the data, and you create a model of the world, and then you have to plan. Then you have to say, okay, this is what I see. Now, what am I going to do? This is the planning. And then the third level of presentation that was given was, okay, now to put this all together, we need a compute architecture, and that's kind of like Project DOJO in particular. Interestingly enough, they didn't talk about the full self-drive chip, the full self-drive architecture underlying, let's say, the inference engine, which is the chip. On the first AI Day a couple of years ago, they did talk about this. So I don't know if maybe that person isn't there anymore. He's one of those famous chip designers, but that's not the point, and I don't want to go into details. Let's get back to, so we have vision as the sensory suite that is used by Tesla to gather information. Karpathy was in particular talking about the problem that the way you can design, I mean, you can design a neural net, of course, any which way you want. And he said sort of the starting point was you have a lot of information, a lot of pixel information coming from the real world into the cameras, and then you have to kind of work your way up towards less and less neurons and more information within the neurons. So in other words, you start with a lower level, which just takes a very limited amount of information. Kind of think of those neurons as pretty dumb, but gathering information. And then you build your way up through the network with neurons that know more and more about the world until you have one neuron left, which is actually the representation of the world. Tesla has said on many occasions before that what they're trying to do is they're trying to take all the information and represent it in one shot into a vector space. So what they're really doing is taking the world and creating a model, and they call that a vector space. So in that sense, they're doing exactly what humans are doing, which is taking information from the world and then create a model that is allowing for prediction. So because this is really what it's all about. It is see what's out there, create a model, and then predict. So in that sense, Tesla is doing exactly what neuroscientists are doing when they study the brain. The brain is a mechanism that is very good at making predictions based on models. This is what we call intelligence, is create a model of the world and then make predictions. So Tesla is very much in that realm of expecting or executing AI at the physical and computer hardware level. Now, Karpathy spoke about this problem, how they create a neural net that takes a lot of information from pixels and then works itself through up to a sort of representation in the vector space that allows for the next level for the planning. And that is something that kind of, I think it was a little over my head in terms of how they do it. For example, rectify data and then use transformers. But in a sense, I think the way what they're really doing is they're taking pixel information, moving it into a form that then can be transformed into a vector space, and then combine that vector space into something that is understandable as far as planning is concerned. And the planning, that was an interesting part of the presentation. The planning is really, okay, what do I do with the world out there, and how do I act? And there's two things that are important here. One is, first and foremost, I have to act based on what I know about myself, my speed, my location, relative to other objects and things like that. And then what this gentleman also said, which kind of caught my eye, was also, how do I plan what others are doing? So meaning I have to not just plan for my own projection of where I'm going, but also what others will be doing. So there's a game theoretic aspect to this whole situation. Now, they didn't talk about the game theoretic, they didn't use the word game theory, but I know Lex Friedman often talks about game theory when it comes to self-driving cars. So there's definitely an element of that. And one of the questions I would have asked if I had been invited is, okay, how do you incorporate, let's say, a world without any self-driving cars, and then how is a world with self-driving cars? See, clearly, if you confront, let's say, a Toyota, Honda, Acura coming towards you, you know that car has no intelligence whatsoever other than the human intelligence, versus if a Tesla comes towards you, you will incorporate that intelligence differently and also plan differently. So I would have been curious to hear how they sort of, kind of, to use a David Deutschian expression, how does knowledge evolve, and how does your behavior evolve relative to the knowledge which is evolving with you? So that would have been an interesting question to ask them. But my hunch is the answer would have been something like, well, in the short term, we're assuming everybody's dumb, and we're just assuming, let's say, we just act based on what we expect normal people in normal situations would act. And this is the other interesting thing they mentioned, that they're using AlphaGo type technology here, which is basically behavioral cloning. So they're when it comes to planning, they also they use basically what Alpha or any kind of game engine would do, which is they play games. They play, let's say I have to go from A to B, given all these constraints, and how would that happen in the real world? I then clone it and act based on that. So there's some sort of learning involved here. I didn't quite understand how they do it, but I would say, just to keep this simple for this episode here, what Tesla is doing is a lot of, again, Andrej Karpathy's job is to represent the world and build a model of the world, and then other people are taking that information and creating a way to behave that is most optimal. And what most optimal means is no accidents, maximum comfort for the driver, maybe also less wear and tear and things like that. So, for example, there was one example that they showed was a car has to make a left change on a left lane change, and then a left turn, and then based on the other traffic, he can do that very fast, or he can wait till the traffic passes by and then make the left turn. But then maybe he has to stop, and then he risks other people bumping into him and things like that. So that was discussed, and I think that is part of the situation here and part of the problem set. Another thing that was discussed within the context of training. So now we're talking about training. Before we go to the hardware side, also on the software side, the auto labeling was mentioned, and this is one of the things that I think Karpathy also has a lot to say. The auto labeling is simply the idea that you have a lot of real world situations, even things like, let's say, road conditions, the surface of the road, all these kinds of things. And it's still the easiest, I guess, to teach a vehicle how to behave in the real world if you can somehow label your environment and then have the vehicle act based on those labels. But how do you do that most effectively? Well, auto-labeling is probably the way to go, just simply because it takes way too much human power. So meaning you would have to say this road is icy, this road has gravel, this, all that stuff. The curb is not straight. So they spoke a lot about auto-labeling. Again, I didn't quite understand how they solved the problem, but it's certainly a problem that they're attacking. And but I think the most interesting thing is that the AlphaGo approach was mentioned, which is something I ask myself many times. Is Tesla kind of losing out relative maybe to other approaches where they are using, or could one just play games from scratch and learn how to drive? But of course you can't do that, because you can't play games in a sense. You can't go in the reality and have a car drive around and crash into people until he learns, or it learns, how to not crash into people. Then the last presentation in the whole AI context was hardware. This was a very impressive presentation, but unfortunately, like many of these hardware presentations, a lot of jargon was thrown at us, and it's hard to say, okay, what are we talking about? 4x, how many petaflops, all that stuff. But in a nutshell, again, I think I want to keep it simple here. What Tesla's trying to do is build a massive training engine, an engine which is simply designed to train on video data. This is it. And within that context, this project Dojo, that's how they call it, they have much, much better performance, lower cost, lower power consumption, all that stuff. So this is it. I think that's kind of the nutshell. They also added a fourth dimension here, which was the humanoid. I can see where Elon Musk is going with this. I think what Musk wants to build is humanoids so that he can send them to Mars. He might also use some of them in factories, but I don't think that this humanoid thing is very interesting right now, and it's a really long-term vision. If you take Neuralink, if you take SpaceX, I think Musk is kind of combining all of these projects into an idea that he could send robots up to Mars, maybe something like that. But maybe what's interesting about the humanoid is that it will be an application of the full self-driving computer into another use case other than driving. And it could be, for example, robots that pick up stuff, or robots that maybe take things from A to B, something like that. It could be useful, but anyway, in my view, not exactly something that I would get super excited, let's say, as a Tesla shareholder. Now, to summarize, I think the AI Day did exactly what it's supposed to do. It sparked interest. It, I think, was very inspiring for researchers and people in that space who want to work for Tesla. I think it showed a roadmap which is clear, which gives people a sense, okay, this is what they're going to do. Now, I might not agree with some of that, but this is where they're going. So they want to use vision to create a model of the world, and then they want to use planning techniques to have the robot act most optimally in the real world. And for that, they need a massive compute engine. That's what they called Project Dojo. And I think for us shareholders, what does this mean? I've said it many times before. The big wealth creation, at least for the first part of this century, will be for companies that can take advantage of Moore's law and take advantage of compute in real-world application. Tesla definitely fits into that. I think it is going to propel the company into much, much more success as far as demand for the products and services is concerned. I think the risk, of course, is that it might not work. There's technology risk here. This is really technology risk, but I would consider this relatively benign technology risk relative to, let's say, other tech risks, such as the battery, the 4680 battery, which in my view is much more, it's a much more of an engineering problem where we're dealing with real physics and therefore a bit more unpredictability. Here, we have a compute problem. We have a pretty good model of how to solve the problem. And it's like they said, it's an engineering challenge, but the roadmap is there. And the roadmap, in my view, is conceivable. It's something that sounds achievable. You build a model based on computer vision. You then build a planning pipeline, and you have a massive compute engine, what they call Project Dojo, to execute all of this on the compute side. So Tesla is a compute company. Tesla is investing heavily in compute and software to solve the transportation problem, take the human as much out of the equation as possible, and that will create enormous wealth for the company. Thank you.